Hello, this is Bobby at Copel TV Repair. Today with a video dedicated to mainboards for the Samsung F series. This is UN60F7050AFXZA, but the same would apply to all boards that are based on the same LJ41 number. I don't see where it's printed on the board right now, but here's another similar board. This is UN55F6400, and there is another one which is slightly different. It's from a smaller TV. This one is UN40X6300. The difference between those two is mostly in the size of the power connector, but otherwise the outputs are the same and the failures are the same and the repair procedure is the same. So this particular one was sent here for repair, and what it does is it just makes the TV click. Now there are different types of failures. I'm turning it on, and we're testing it on a different one. We're testing it on 60F7100. That's the one that the chassis that we're using, while this is 60F7050. There are some minor differences between those. The TV, let me see why it's not clicking anymore. It should be. Let me reset that and see whether we will get it to start ticking again. It may be totally dead. It may be clicking. Different things may happen. It was clicking until a while ago, and I left it like that and went to do something else, and it clicked for a while and then it stopped. The clicking was coming from the relay, but this is another possible condition. It may be totally dead and do nothing. The very first thing that you want to do to narrow it down to the main board is disconnect the power from between the main board and the power from either side. I'm disconnecting it from the power just because it's a little easier. And what should happen when you do that is the backlight should come up, and it tells you that the LED is good, the LED strips and the LED panel is good and the power is good in order to be able to power them. If the backlights do not come, here's I'm putting it again, when the main board is connected, then you do have a problem with either the power supply or the power supply and the LEDs, or just the LEDs. It's a different troubleshooting process. But if they do, and if the TV just clicks when the main board is connected, or it doesn't do anything, like now with this one, then you have suspect in the main board. And what you do with the main board to confirm that, it's not again 100%, because there could be different type of failures, but this is a very common one that we see in the F series, is the main processor that actually failed. And one way to tell about it, or identify it rather, is to find a short on the data differential signal pairs connections on the HDMI port. So what I'm going to do is I'm putting my meter in diode testing mode. I'm using one ground here, and what I'm looking for is, you can see on the HDMIs there will be 4 pairs for the data signal. So this and this is one pair, differential pair. This and this is the second. They have ground in between them. So this is 1 plus 1 minus, 2 plus 2 minus, 3 plus 3 minus, 4 plus 4 minus. And there are some additional ones. The 5 volts, the detection of the 5 volts, etc. driving signals. But most commonly when something is bad, what you want to find is consistent same resistance between ground and the data wires, each one individually. So this one and that one, I still have the ground, so connection is good. The lack of anything here is bothersome by itself. There should be a resistance, let me find it somewhere, to demonstrate what you should be looking at. It's another HDMI. Okay, that one is flat out short. And that tells you right there, okay, this is about what you should be having. On the second one, you should be having something in the range of 0.6, 0.7 in diode mode, 600, whatever, high, above, definitely above 500 ohms. But you should be having the exact same thing on the positive and on negative line of the pair. And on this one, as you can see, let's see if I can make it better, you have a flat out short. That tells you that possibly from here, not necessarily, a power surge hit through here. There is no HDMI selector as in many other types of boards. The signals go straight from the HDMI port to the main processor. The main processor is not as easily removed as I do it. I just put that after, I just figured it will be a good idea to do that. The processor for those boards is Samsung 30, I believe. Yeah, Samsung 30. And unlike other types of boards, like those visuals that we do a lot, where there is an HDMI selector IC which gets busted whenever there is a power surge coming from the HDMIs. On the newer generations, more and more we see, not all of them, but more and more we see nothing between the data port and the HDMI. And the only thing that can be done is this can be put on a machine to have the main processor replaced. Now I'm not going to be showing you how to do that, that's a whole separate topic, but this is what needs to be done and this is what is done. I'm going to pause this and start the process, and maybe I will, there are different types of videos out there showing how this works. And what we want to do is get that fixed, push down a little higher, make sure we have the proper, we want to be removing it. Alright, and get it started. Then see what are we doing. I'm going to pause here and continue later on. Of course, I have done, I don't know if you can see, but I have prepared this, and there is a flux underneath the processor for easier removal. And this is going to go until it gets out. I'm going to pause here and maybe show you how we're replacing it and see what happens afterwards. Stay put for now. This is the process just a few minutes later, before, here's the top of the curve, just seconds before the machine picks up the chip. And I just thought this might be of interest to someone watching. There it is. The balls are melted, it's pressing it down, sucking it up, and this is what we have down there that we'll have to clean and get ready for a new processor in a few minutes. Putting you on pause again. This is part of the next step. I don't have the equipment to make quality videos, and I'm not really at this stage trying to, just because it doesn't pay for us. So from the selective snips that you will see, you may get the impression that we're not doing this quite right. That's not the case. This is the very first phase, and I'm doing it carefully before I start the delicate portion of this removal, and I better do it fast. I just don't have good equipment to be doing recordings while I actually work, but following this I will clean the processor in a better way with the help of some of that. I'm going to do it fast and clean it even more, and then I will put it in again whenever we're ready to place the new processor. Hold on for now. Here is the cleaned surface for the new IC. took a while, and actually there's one last step that I need to do before putting the new flux for the processor that will go on top. Gotta clean that very carefully. This is a hard thing, and again, I'm not trying to teach anyone how to do it. I'm just showing something that somebody may find curious, applicable to their board, also pretty much proving that we really do it here, even though I guess with our feedback online shouldn't be convincing of that. Anyhow, when the time is ready for putting the new chip after applying the flux here and leveling it and thinning it enough so that it doesn't overflow, and this is crucial for those really small pads, I will plug in again. Now, since I don't have a camera, I have to show it through the microscope that I'm using. But it's very crucial that before anything is finalized, this is being reviewed. Yesterday I had a board which wasn't working after having replaced 2 processors on it, and it's because one of those small pads, it's so hard to get it stable, one of those small pads was broken. It was ripped off. Most likely it was when me or someone else here was cleaning it, and we just didn't see it, just like I didn't see it for a while. On this one, I thought that I saw something before, a very small, tiny piece of copper while I was cleaning it, and I cannot find it anywhere, so I'm going to search for a little longer. But this is very crucial, even for experienced work. They have to be checked because it can save time and parts and everything. Sometimes pads are repairable, sometimes it's just too bad. Yesterday I started fixing that pad that I saw broken because it was fixable, and then another one broke, and then I saw another one, and with 3 I just put the board in the bin with trash. But I still don't see anything here. Anyhow, I'm gonna triple check it and come back once ready for laying the new processor. Now it's already in, and it will have to be picked up and aligned. Now this is one of the 2 major reasons one uses a machine and cannot do it at home. A machine can position that precisely enough to actually be worth doing, and I'm seeing some small wire. Anyhow, this is how it's gonna look, and this is not something that you can do on your own easily at home. The positioning is very, very crucial for those type of chips, especially the small balls ones, and this is why you do need a machine to do that. Placing it to the top of your eye is not gonna work. I'm gonna pause now to align it properly. It's not so much fun. It's let me see, first I need to make sure that it's not rotated, then I have to make sure that it's zoomed properly by positioning them one on top of the other. One set of it is the pads that are on the board, the other is the balls that are on the processor. This arm here has cameras facing top and bottom, and the images just mixes them. You can see how, well, you can't unless you're experienced or I explain it in details. I have to make the 2 align perfectly so that when the machine drops it down, everything falls the same, and they look pretty decent to me. There is a very slight difference at the lower right corner, like I can do some rotation to align them better, and every time you do a rotation, usually that's compensated further by alignment. Now they are almost perfectly one under each other, and if I move the processor higher, they get aligned. I saw a strain of something here. I believe I will have to remove manually before the processor gets dropped. Let me see with the light. And I don't see it now. Sorry, what was that? No. It has to be clean. Yeah, this doesn't look good here. This definitely is a piece of cotton or something else, splint. Should not have been there at all, but somehow made it there. And what I'm doing here is not very technologically advanced. The flux was already cold, and I got something off that top. I think it's gonna be fine. One thing would be to add a little flux so that there is some, but I'm gonna be counting on the one that got on the ball when the processor was down before it was picked up, to hope that there is enough of them. So what I'm gonna do is I'm gonna tell it to go and put it down, and there it is, and there it is. Make sure that it doesn't move anywhere when it goes up. Okay, and baking begins. Not much fun watching that, so I'm going to put it on pause again, and we'll get back. We're getting close to the point where the IC will start melting, or the balls will start melting, and this may be something that somebody is curious to see. I can see they already did. When they do melt, they become shinier, and because they are so tiny, they become almost invisible. It is important that this doesn't get overheated, but it's also important that it does get heated enough so that all of them evenly go up. All of them evenly melt, and the chip goes evenly down. Now, oftentimes with those small chips that are very light, the problem is that it doesn't get melted all the way in. So this side may get more heat than that side, or this end, and I've seen cases where it just wouldn't work the first time after it's placed, simply from being afraid to overcook the board. So this is it. I'm going to give it a little time to cool off, and then I'm going to stick it in the TV and test. Now, one important thing will be after we see it working, if it works, to test all the HDMIs, because oftentimes when an HDMI gets hit, there might be some small resistors that are usually not part of the data signals, but from the power lines, the detection of 5 volts or the 5 volt power for the output device, that get burnt. And sometimes the port through which the surge came wouldn't be working. Sometimes all of them will work, and sometimes, of course, none of them will work if something else has failed, or if this procedure wasn't done properly, or if the chip that came from China wasn't done good. There's so many things that could go wrong. I'm going to be putting a pause for now. Okay, so here's the board, again connected to the same TV. Power, output, power, everything powering on. Clicking, backlight, no backlight. Heat, oh, it's heating good compared to before. Backlight, no backlight. Power off, Power off. Power on. No backlight. Okay, this was not supposed to be troubleshooting video, but it's turning into one because I want to get that board working. So let's take it off and see if we can find anything else that is bad. Okay, back to the board. And as I said before, there are many things that could have gone wrong. Starting from the processor that is coming from China, and God only knows whether it's working or not, but the other ones that we used before were working. So I will say, let's give it the benefit of the doubt. Let's say that it does work. Then the soldering could have been, I could have missed a pad, or the heating could have not been quite even. This is always a possibility. But because the last few boards that we did here with that same type, with those processors, were good on that machine, let's say that this one was fine. So the first thing that we want to do when there is a problem like that, we want to go over all the power points, see if we find any apparent shortage. We could have done the same before. I started with the HDMI because I do know that HDMI goes bad very often, and this is a good place where you can find quickly whether you need to replace the main processor or not. Power sources best identified by those small coils, usually around driving chips. Those are current rectifier, not rectifiers, smoothers, filters. And usually if you find a very low resistance somewhere around them, that's a good indication of a problem. Very low, something that's really subjective. On 1 volt rectifier, it can be really low. On a higher one, it can be a lot. Now, something like 9 ohms, 10 ohms is very little. Now, if it's 1 volt, which is sometimes used, that may not be excessively low, but it's still pretty low according to standard. So once I see that, this one is high enough for something, so I'll be happy with it. The others, 5. This is extremely low on this one, 5 ohms. So for reference, and this is another benefit of, specializing into repairs, you always have a board that is, if not working, then at least good for reference. Preferably working, so that you know that it's a reliable reference. The same thing, let me switch the ground, on another board, measures 340 ohms. And that one here that was nearly 5 is 140. So there is a problem somewhere. And there are 2 major possibilities here. Spill, when this was soldered, 2 neighbor balls shorted. And it's a common possibility with some of the larger ICs. With this one, as I said before, last few times we did it, there were no problems. I would entertain another idea for a moment. Now, because those all lead to the main processor, I can again check their own pins also to show how things were. Going at the very first pin here. And there you go. Where there was a short before or nothing, right now there is 742, reliable 0.742. That's a pretty good indicator. And I can go through all of them and they all test fine. But I just assumed the problem would have come through the HDMIs. In reality, it could have also come from the antenna input or through here, the LAN cable. Power surge could come through all of those places. So one thing that I really want to quick test before I go to somewhere else is to get resistances on the tuner here to ground. Let's first make sure that I do have reliable grounds. Okay. Do I have short anywhere on the tuner? And normally I shouldn't, because the tuner is actually separated from ground. Nothing here. No solid sound, just. And then I want to do the same with the network input. And this, even though I believe it shouldn't be grounded, it looks like network is also separated from the ground. But this, because it's on that huge pad, it might be. Let's say, I will check on the other board, but let's say move to the next one. This one is not connected apparently to anything. The odds of both of them being shorted are really low. And this one, and that one, because of that one. We have so many shorts here, and this one, and this one. Given how many shorts there are here on the lamp port, and just for a quick reference, again, here is a good board. Here is this. And this is how this sounds on a good board. Nothing, 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 nothing. Well, those are data channels. They shouldn't be grounded. They, similar to the HDMIs, go straight to the processor. So that means that either this processor is screwed, or the soldering got shorted somehow, or there is something between the inputs. I think I'm here, and the processor. This could also be shorted itself. There may be protection inside, or this small IC here is actually just a protection against high voltage on the data lines of the lamp. It's basically Zener diodes inside. It's a matrix of Zeners, and they short out when there is an overvoltage. This supposedly protecting the processor. Of course, they don't necessarily, but they do what they can. So this might be bad as well. And there might be something inside the port, even though I doubt it, considering there is an external protection. There might be something inside the port that does the same thing. And one of the things that I want to do in regards to that is this. Let's say we said we have shorts here. Let me see what will happen if I remove will I have shorts on the track or on the pin itself? Oh, come on. I have short on the pin. I don't have short on the track. On the track I have 300 ohms. To me, this sounds suspicious of this whole connector, which does have a small board inside. It may be reason for the shortage. Let's see what happens. Actually, I'm going to put this on pause and have it removed. Okay, so the connector is out, and let's see what we have on the data pins. Oops, that wasn't on. 3. Alright. It's too short. It's too short. And those are, again, data lines that go straight through the protector into the processor. So either the processor is bad, or the balls spilled and shorted. But to ground all of them at once, honestly, not likely. Shorted processor, more likely. Or this just came through the lamp port and the protector chip failed. So what I'm going to do is I'm going to just take it out. But I will need both my hands for that. So pause again. Okay, the little protection surge protector IC is out. And this is what we have here. Come on, this is the chip that is out. And those are the lines. And there is no short here, and there is no short here, and there is no short here, and there is no